Example 8 says graph one period of the following functions and list their amplitude, period, and phase shift. So we have y equals 3 times sine of 2x. So let's calculate our period. We know that it is going to be 2 pi over k, and in this case k is 2, so we have 2 pi over 2, which is pi. Now there is no phase shift, or you can think of the phase shift as 0, because we are not subtracting or adding a value inside of the parentheses. So the period is pi. We know that the amplitude is related to the a value, which in this case is 3. And the phase shift is 0. And lastly, we know that this +1 on the end indicates that we have a vertical shift up 1 unit. Okay, so here is our y-axis, here is our x-axis. We know that we are graphing one period, so I'm going to put pi there. I'm going to cut that in half at pi over 2, cut that in half at pi over 4, and I know that this here is at 3 pi over 4. And normally our graph starts at 0. And if that's 1 and that's -1, so what I have graphed here, that is y equals sine of 2x, but we also need to do a vertical stretch because of the 3, and we also need to do a vertical shift up 1 unit. All right, so our graph is actually going to start at 0, 1, and then our amplitude is 3, so I should be going up 3 to get to the highest point, and then down 3 to get to the lowest point. And I'm going to graph this in a different color. And that is what our graph will look like for y equals 3 times sine of 2x plus 1. All right, for part B, we are asked to graph y equals 1/2 cosine of pi over 3 times x minus pi over 3. And recall from up above that we want our function to look like y equals a times cosine of k times the quantity x minus b, like that. And so what we're going to have to do is we need to factor out pi over 3 inside the parentheses so that we can identify what the k value is. So now this is going to look like y equals 1/2 cosine of pi over 3. And if I factor that out from both terms, I'm going to get x minus 1 left over. So our amplitude is equal to the absolute value of our a value, which here that's 1/2. So the absolute value of 1/2 is equal to 1/2. And our period we calculate by doing 2 pi over k. And in this case, our k value is pi over 3. So we're going to do 2 pi divided by pi over 3, which is the same thing as 2 pi times 3 over pi. And the pi's would divide out, and so our period ends up being 6. And then the phase shift is the b value. So our b value is 1 in this case, and this tells us that we are shifting 1 unit to the right. Okay, so here is my y-axis, here is my x-axis. I know that my maximum value is going to be 1/2 and my minimum value is going to be -1/2. And I know that we are shifting to the right 1 unit. So this is 1, and I know that my period is 6. So that means that the distance from here to here, whatever this endpoint is, has to be 6 units. And if that distance is 6 units, then this x value here would have to be 7. And the way that I like to split up my axis is I take the midpoint of 1 and 7, which is 4, because 4 is 3 units away from 1 and from 7. And then I take the number that's halfway between 1 and 4, which you can take the average of the two numbers, and if you do that, you would get 2.5, and then the number that is halfway between 4 and 7 would be 5.5. And cosine, we know, starts at the top. Oops, that's not where I meant to put that, because it's shifted to the right 1 unit, so it's going to look like that. And our normal cosine, looks something like that. And so we have identified the amplitude, the period, the phase shift, and we have sketched our graph on the xy plane. Now we want to utilize our graphing calculators a little bit. Example 9 says, determine the appropriate viewing window for f of x equals 30 sine of 0.005x in radians and graph using your calculator. So in order to decide on an appropriate viewing window, we need to think about our x-axis and we need to think about our y-axis and how that is showing up on our graph. So let's start with the y-axis. I think that's going to work a little bit easier. And we know here that our a value is 30, and so our amplitude is equal to the absolute value of 30, which is equal to 30. So that means that the highest point, because there's no vertical shift, the highest point that our sine graph will attain is 30, and the lowest point will be -30. And so that will be important when we're deciding our window for the y values. And let's now think about the period. The period is going to be equal to 2 pi divided by k. K is the coefficient of x, and so in this case that is 2 pi over 0.005. And let's see, that is the same thing as 2 pi divided by, this thing written as a fraction is, the first spot is the tenths, hundredths, and thousandths. So I could rewrite this as 5 over 1,000. And then if we multiply by the reciprocal, we get that, and that is equal to, let's see, 2 pi times 1,000 divided by 5 would simplify to 200, and 2 pi times 200 is 400 pi. Now, recall that pi is approximately 3.14, so this is about 1,256. Okay, so now we can use this information that we've found on our graphing calculator. Okay, so first things first, I want to go to mode, and I want to make sure that my calculator is in radians, which now it is. And so I can go back to the main screen, and I'm going to clear that. In the top left corner here, I'm going to press y equals, and then I'm going to clear whatever I have there. and I'm going to type in 30 times sine of 0.005x. And then I'm going to come up on the top row, the second button from the left says window. I'm going to push that. And remember that I said the lowest y value it's going to attain is negative 30. And so I'm going to come here to the y min. And since it's negative 30, maybe I'll make it a little bit lower than that and say like negative 35. And then the y max, I'll make that positive 35. Now, I want to see one full period. And so I also want to make sure I see the y-axis. So I'm going to make this a little bit smaller than 0. So maybe negative 5. And then the x max, I saw here that the period was 1,256. So maybe I would make this something like 1,260. So now if I hit in the top row, the rightmost button says graph. If I hit that, I should be able to see one period of our sine function. Awesome. So that is our graph. And I know I'm a big fan of Desmos, so maybe we can also see this really quick inside of Desmos and what that looks like. All right, so I'm here in Desmos. I'm going to type in my function, y equals 30 sine of 0.005x. And the way that I change my viewing window on Desmos is I come up to the right corner here and click this little wrench, which stands for the settings. I like to click this one so it's a little bit like more bolded. And then here we can change our window. The x min value, remember I made that -5, and then we made our x max value 1260, and then our y min value, we made that -35 and then +35. So now we have a much better viewing window and we can see one full period graphed of our sine function. It's actually cut off a little bit on the bottom, so I'm going to zoom out slightly. Now we can see more than just one period, but the bottom got cut off, so I wanted to show you that part. So that's how we would go about graphing this in Desmos. Example 10 says graph y equals sine of x, y equals 2 times sine of x, and y equals sine of x plus 2 times sine of x. Can you see how the functions are getting added? So I'm going to show this in Desmos. We have y equals sine of x, y equals 2 sine of x, and then y equals sine of x plus 2 sine of x. And I want to make sure that I change my viewing window. This number is much too large, so let's make our x min value -10 and our x max value +10. And then these are much too large as well, so maybe let's make this -5 and +5. Okay. So now we can drag this around a little bit. The blue graph is y equals sine of x, and then the green graph is y equals 2 times sine of x, and we know that 2 is the amplitude, and it causes a vertical stretch. And then if we add those two functions together, we get this purple graph, and notice that it's even more like elongated, and it appears to be more of a vertical stretch. And the reason that is because if you added these together, you'd get y equals 3 sine of x. And so hopefully that is clear to folks. I'm going to unhighlight these ones. And so hopefully it's clear that these are the same graph. If you were to add these together, it becomes 3 sine of x. And so now our amplitude is 3 there.